Probe 1, we're T-minus 30 seconds to launch window.
Roger, Capcom. We're initiating the primary engine startup. Plasma level at threshold.
Fusion propulsion in 10, 9, 8. Commence helium burn. 3, 2, 1. Probe 1, you're looking good.
Well, Ed, we're on our way.
I can't wait to see what a black hole looks like up close, Charlie.
Relax, Ed. It's a long way to the center of the galaxy.
Yeah, but it's incredible that there might be a black hole at the center.
Probe 1, you're now approaching the Perseids meteors, expecting communications breakup. Advise that future communications should be through Geosat 4. We'll be in blackout until your echo calculations are complete.
Put it on the screen, Ed. Okay, let's begin trig calculations for the transmission angle.
Trigonometry, the study of triangles, was used in Babylon 4,000 years ago. It's an important branch of mathematics and serves as a tool in astronomy, navigation, and surveying. By using the relationships between the sides and angles of triangles, the ancient Greeks tried to establish the size of the heavens. Being an orderly people, they arranged these relationships, or ratios, in tables. The ratios most commonly used today are sine, cosine, and tangent, usually written as sine, cos, and tan. To work with these ratios, we must use right triangles. Right triangles have one 90-degree angle. The hypotenuse is always opposite the right angle. The names of the other two sides depend on which acute angle we're talking about. When we're considering angle B, AC is the opposite side, and BC is the adjacent side. The names switch when we're looking at angle A. The opposite side is always opposite the selected angle. With the sides named, we can now define the trigonometric ratios: sine, cosine, and tangent. The sine of angle B is the length of the opposite side divided by the length of the hypotenuse. The cosine of angle B is adjacent divided by hypotenuse. The tangent of angle B is opposite over adjacent. These ratios cannot be deduced. Like phone numbers and lock combinations, they should be memorized. We never see sine or cosine by themselves. It's always the sine of an angle or the cosine of an angle. Let's put in some numbers. The sine of angle B is opposite over hypotenuse. Or sine B is 7 divided by 8.6. The cosine of angle B is 5 divided by 8.6. And finally, the tangent ratio is opposite over adjacent. So tan B is 7 divided by 5. Sometimes it's convenient to use the Pythagorean theorem to find the length of a side. In a right triangle, the square of the hypotenuse is equal to the sum of the squares of the other two sides. With any two sides, we can always find the third using the theorem. Up to now, we've only used triangles in this position. But triangles come in many orientations. To identify the sides, first look for the right angle, then the hypotenuse. Next, look for the angle you're concerned with. Opposite this angle is, of course, the opposite side. The remaining side must be the adjacent side. Now let's see how trig ratios can be used to find an angle K. Again, with some numbers, the sine of angle K is 5 divided by 6.1, or 0.82. A calculator, or trig tables, gives angle K as 55 degrees. Trig tables relate angles and trig ratios. This means that if you have one of them, you can look up the other. In the table, the sine value of 55 degrees is 0.8192. Because all three sides are known, we can also use the cosine or tangent ratios to find angle K. Now let's see how Ed and Charlie can bounce their transmissions off the satellite to lock their signal with Capcom. GeoSat-4, a geostationary satellite, is 3,000 kilometers from Capcom. Probe 1 clears the meteor shower 4,500 kilometers directly above Capcom. At that point, they must determine the transmission angle to the satellite and bounce the signal to Earth. Probe 1 can then lock its transmissions onto GeoSat-4 for the rest of its journey. GeoSat-4 to Capcom and Capcom to Probe 1 make a 90-degree angle. Working with angle P gives the opposite side and the adjacent side. The only trig ratio that uses both of these sides is the tangent ratio. So the tangent of angle P equals 3,000 divided by 4,500, or 0.67. Angle P, then, is 34 degrees. Upon clearing the meteors, Ed and Charlie must aim their transmissions 34 degrees away from the vertical to re-establish contact with Capcom.
That ought to do it.
Capcom, this is Probe 1. Do you copy?
Probe 1, you're coming in just fine. We have transmission locked. What's your status?
Capcom, glad to be back. We're on our way to rendezvous with Sharon Checkpoint.
Roger, Probe 1. Sit back and enjoy the scenery.